This is PZ Myers, and I'm the guy who hosts the blog Pharyngula over on scienceblogs.com. And with me today is
Abby Smith. I am a graduate student at the University of Oklahoma, and I blog at Endogenous Retrovirus, also at Science Blogs.
Right, scienceblogs.com/ERV. I remember that one well.
Yes.
All right. So we're just here to talk about whatever.
Yeah.
So what do you want to start with?
Well, I think I'd like to start off with epigenetics, because you just had a post a few days ago about a conference, I guess, that's being held in Italy.
Oh, the Altenberg conference.
Yeah.
Yeah.
Well, I know a lot of the bigwigs there are bigwigs in epigenetics, and I know that was it Susan Mazur was her name. She was implying that all of a sudden evolutionism was going to have this gross revisionism because of epigenetics. And I think we should talk about what epigenetics is, kind of explain it to everybody so they can understand that it's not magic, it's just new. Right,
it's fairly new, but Mazur has just mangled that story so much. Massimo Pigliucci also had a recent post on this particular subject where he was pointing out that this is ordinary science where people get together in these meetings and they talk about new things. They're just exploring. They're coming up with ideas. They're not planning to firebomb Darwinism or something silly like that. And that's kind of the tone that Mazur promotes, is that they're radicals who are doing amazing things, and they're doing great work. But it's more interesting than what she makes it out to be.
Yeah.
Okay, so you work on viruses, and I work on complicated, messy, multicellular organisms, and so we probably have slightly different views of what epigenesis is, right?
Yes. Well, just to give a broad, well, at least my broad understanding of what epigenetics is okay. So you have all this DNA in every cell, and it's got to be wound up really tight to actually fit into a nucleus. And you do that by wrapping DNA around histones. They just imagine like 8 beach balls stuck together, and the DNA is wrapped around these beach balls. And if you change, just alter these histones in one way or another, you can affect how tight the DNA is wound up around the histones, and then in turn you can affect how the transcription machinery can get in to express genes. So, I mean, that it's part of the reason why a neuron is a neuron and a skin cell is a skin cell. Every cell has the same genome, but it's just expressed at different levels, each of the proteins. So, when it comes to viruses, I think of endogenous retroviruses, and these guys are genomic pirates. They are the definition of Richard Dawkins' selfish genes. They exist only to replicate. And that's a burden on your cells. So from my point of view, epigenetics was a way our genomes have evolved to keep these pirates in check, to keep them quiet, to prevent all of your cells from expressing retroviruses.
Oh, that is a different perspective than mine. I mean, I agree in general with your definition that what we're looking at is information outside the raw genetic sequence, that you can have cytoplasmic information, you can have things like modification of DNA, like methylation, that you can have histones, for instance, that are specifically modified specifically with, for instance, a lysine.
But I will say, though, that it's outside the genome, but at the same time, the proteins that make these modifications are still encoded by your genome. So if you have a protein that's better at doing one modification when that particular nutrient is low, or it's not as good, I mean, it's all still genetics. One thing that gets me with epigenetics is people think that it's this magical thing outside the genome, but no, it's still proteins encoded by the genome acting on the genome.
Right, but there's, it's also extra genetic, and that's I try to teach this stuff to students in introductory genetics, and this is always a stumbling block for them, is that they're so used to thinking, well, you look at the sequence is telling you what gene is there, what protein will be produced, but then you got to tell them that there's these regulatory structures, and there's things like methylation that can shut down a gene, which is a chemical tag that's placed on the gene, on the sequence of nucleotides, and it's independent of the sequence. So that's a key element there, is you need to modify that sequence chemically or by other factors like the histones you mentioned. Specific histones can downregulate or activate even. And another one that I've been reading a lot about lately is localization, that what you can influence the behavior of a gene, its level of expression, by the three-dimensional localization of that gene in the nucleus, that the DNA actually folds in particular ways, and that certain groups of genes will cluster together, and then you can have single regulatory elements that influence a whole bunch of genes.
Okay, that's a new one for me. I've only heard the DNA methylation and, of course, the histone, but not its actual 3D location within the nucleus.
Yeah, there's some really interesting work that's being done in olfaction, that olfactory receptors, we have all these olfactory receptors. What is it in mouse? There's something like 1,300 different olfactory receptors, and any one cell will only turn on one of those. So each cell makes its own unique olfactory receptor, which makes sense. You don't want to turn on every single olfactory receptor protein in a single cell. You just want the one that cell's going to respond to.
Yeah.
And it looks like one of the ways they do this is that they have a single regulatory node, something called the H locus, which is responsible for activating the olfactory receptor. And what happens is that the DNA folds so that only one of the olfactory receptors is actually in the right place to be facilitated by the presence of the H gene.
That's cool. New to me.
So it's a simple way just to switch on one particular gene.
Well,
and of course,
it's all about expression too, because we hear all the time that humans and chimpanzees and other primates have so many genes in common, and our genome is so alike. Well, then what's the difference between a human and a chimpanzee? It's expression of the genes that we have.
Yes. Well, and also, let's switch it over to my subject, which is development. Development is all about this regulation of the expression of genes in cells, and one of the key principles that we've noted in developing systems is that there's this kind of progressive restriction. There's this hierarchy where you go from totipotent to pluripotent to multipotent to the differentiating cell. So each of those steps is a restriction where you lose a whole set of capabilities. Once you've gotten on one particular pathway, you can't go backwards except under certain extreme circumstances. And that's also an example of epigenesis, because each of those cells is acquiring some modification to its pattern of expression that is passed on to all of its daughter cells.
And embryos, don't they get stripped of most of their epigenetic profiles, like the histone modifications and stuff, like right after fertilization?
It's complicated.
Yeah.
They have their own pattern, and the freshly fertilized egg is not just a blank slate. It's already got its own predispositions that make it a unique cell in its own right. I'm trying to think what are the best examples of this. Oh, so one really good example is X chromosome inactivation. So you know all about this.
Yeah.
Females have to have one X shut down for dosage regulation or dosage compensation, and that is also an epigenetic process where you shut down this entire chromosome and all the genes on it using these mechanisms like histones and methylation and so forth. One of the cute things about it is that, for instance, in mice, all this work is done in mice.
Yeah.
I don't know why. Yeah, zebrafish are cuter. But anyway, it's done in mice, and what they found is that in mice, for instance, the paternal X chromosome is always inactivated. So when daddy mouse is making his sperm, one of the things he does is he does X chromosome inactivation, shuts down the entire X chromosome in his sperm. And so that gets into the egg. You've got a fertilized zygote, and apparently for a little while it's operating solely on the maternal X chromosome, but then there's this process where it opens up and removes the epigenetic restriction on the paternal X chromosome. So for a brief period of time, it's got both X chromosomes working away, and then it randomly shuts down one using the same mechanisms or similar mechanisms that were used in the production of the sperm. So lots of examples like that where cells are using biochemical processes to shut down particular patterns of gene activity.
To bring it back to viruses for a second, I know...
Do we have to?
Yes,
no,
we always have to.
Yes.
It's all about viruses. Well, what I think about with embryos and epigenetics is maybe a lot of the spontaneous abortions we see, maybe a lot of just the failures in fertilization might occur if you don't reset an epigenetic pathway, an epigenetic profile appropriately. And then all of a sudden all of these endogenous retroviruses that were previously silent are free to jump about the genome to screw everything up.
Uh-huh.
So I'm just making that up. I don't have any data to support that yet.
Well, this is kind of a murky area. I mean, I'm thinking back to some of the stuff I've read on epigenetic regulation, and in the embryo, I think they only know like something like 100 genes out of the 20,000 that are in the human genome that are epigenetically regulated by whether they're inherited from mother or father. So in one sense, it looks like it's a small proportion. But the thing is, I don't think that they've studied them all. There's a lot more to be done.
And I think there's more modifications than we know of right now. There's one that I hear of a lot called biotinylation that's very new. And,
yes.
Of course, what I've read about it is that it's associated with the promoter region of endogenous retroviruses. But, again, it's all very new. So whether anything ever comes of that, who knows?
Yes. Yeah, and of course the other problem is it's extremely complicated. Probably one of the best examples of epigenetic regulation and development is all this work being done on the polycomb. Polycomb is this gene complex that is important in maintaining and regulating Hox gene expression. The pattern expression that you've got in your. And I have to confess this. I have tried to read some of those papers, and boy, are they tough. This is complicated, abstract stuff. That part of it is because they don't know the whole story yet. They're trying to piece it together. But it's one of those things where it's good practice to read it, because what you're doing is seeing science in progress. You're actually seeing people striving to reach a deeper understanding of a complex process.
And I love the hypothetical answers, and then to read that same paper 10 years from now when we actually know the answer, and to see their hypothetical, well, maybe it's because of this and maybe it's because of that, to see how far the process has come. I just love reading old papers to see them make those hypotheses. Oh, yeah. Well, some of us are of an age that we lived through the period when those papers were written. Well, yeah. I love doing that with the HIV papers. It used to be very new, and they're like, well, some viruses always use this cell type, and some viruses use that cell type, but we can't figure out why. And then they finally figured out it was because of co-receptor usage, and it's just like, oh, that's so cute. They were trying so hard. They got it, So. Yeah, but then you got to remember, we're in the same position now. Yeah. So. Just wait. Some graduate student 10 years from now is going to be laughing at you. Yeah, thinking, oh, that's so cute. She thought embryos had anything to do with endogenous retroviruses. Right. Yeah, but again, getting back to Susan Mazur, it's complicated stuff. It's fairly new, and it's such an abstraction at this point. And basically, what this is a story that complicates the genetic story that we're all familiar with.
And what it means is that this is an opportunity for the people who are interested in sowing doubt and confusion and chaos to come in and tell us, oh, we don't know anything. We're also ignorant. And so
there's something else. There's something else out there. They always, look, we didn't know about epigenetics. Maybe we don't know about angels and ghosts and crystal healing.
They don't say it quite that blatantly,
Yeah.
but you can sort of see the subtext is if we don't know everything now, then that means that every cherished myth that we have might be verified someday, which does not follow, but it's what they want to promote.
And it's what they feed off of. So I just
Yes.
wanted to bring that up so listeners could know that, it's not magic. Epigenetics is not magic. It's new.
Yeah, and all of the stuff that these people at Altenberg are talking about, it's really interesting stuff. I mean, what else were they planning to? They're planning to talk about things like evolvability and modularity in the genome and so forth. Concepts that are gradually emerging from our understanding of molecular biology and genomics. They're not going to throw evolution on the rubbish heap. What they're going to do is refine our understanding. So it's all good.
Well, I guess continuing on the line of evolution, the other thing I was kind of excited about was the Linsky paper and study. That was awesome.
Yes, it was. Linsky's been around for a long time, and he's constantly putting out these amazing, wonderful papers that are documenting these fine details of an evolutionary process in these organisms. It's also interesting because we've really seen clearly what the creationists are trying to do with that story, aren't we?
Yeah.
We should probably explain the story, right?
Yeah.
So
Go ahead.
Oh, it's such a sweet story. We're fighting over who gets to tell it, right? I'll let you go first.
Okay. Well, why I was interested in this study is because I'm doing something very similar with HIV. So what Linsky did was take a population of E. coli bacteria, and I don't want to say he gave them a task, but he kind of did. He restricted amount of a nutrient they could have, and then he passed these cells for 20 years in this restricted environment. And he found at the end that he had bacteria that could get around that restriction and utilize a different source for its nutrients. Do I have that right?
Yes.
Okay.
But and it's a source that other organisms have been known to use, but E. coli apparently does not.
Okay.
So it was unusual. And then, of course, the other key feature of this experiment was he maintained multiple strains at a time. So he's doing these parallel processes in evolution. And he was also freezing samples, what was it, every 5,000 generations, something like that?
Yeah.
So he's got their ancestors all frozen away in a freezer. And he can go back to the ancestors anytime and see what they were like. So he can basically replay evolution.
He's got his own transitional fossils that he can go back and study at any time to see exactly how they behaved. Right.
Yeah, and his paper was nicely written, a very clear paper, and he was talking specifically about that old idea that Stephen Jay Gould really pushed, which is the idea of historical contingency, that if you could rewind the tape of life and play it forward again, Gould would have said, no, you're not going to get the same thing. You're going to get different patterns every time. That it won't all converge on one solution every single time. And here's this wonderful setup where he can do exactly that. He can rewind the tape of life, at least on this little culture dish, and play it forward again and ask, do we get the same things happening? And the answer is that no, you don't. That certain lines are unique, that they have their own unique history, their own unique pattern, and they don't necessarily play it back again every time.
Well, I'm going to try something very similar, except with HIV, in the hopes that I can identify the exact molecular determinants of fitness and the molecular determinants of transmission. Because right now, I'm sure a lot of people have heard about the HIV vaccine trials have just been failing left and right. And people have come to the realization that we don't understand the virology, the evolutionary trajectory of HIV. We don't understand it as a virus enough to design a vaccine. So what I'm going to do is use evolution to answer that question for us. In patients, you always have genetic bottlenecks, and patient 1 might be infected with a totally different HIV strain than patient 2. And so what I'm doing is taking kind of a white mouse HIV, just a lab strain, standard, everybody's got it in their laboratory, and I'm going to randomize particular portions of the genome that we know are really important. And then I'm going to let evolution do its work. I'm going to put it on different types of cells. I'm going to give it different tasks and see what HIV does under those conditions. And then hopefully I will be able to identify the guys that are really good at getting across mucosal barriers. I'll be able to identify the guys that are really good at evading this type of cell or that type of cell. And so we want to vaccinate against the guys that are great at being transmitted. We don't need to worry about the guys that can't make it across. So why vaccinate against them?
Uh-huh.
So yeah, I'm letting evolution do all the work. I really just randomize the sequence and let selection occur.
And then the idea would be that you would, for instance, identify sequence variants that are particularly good at a particular task,
Yep.
and you would then be able to say, okay, well, this part of this protein is responsible for translating it across a membrane?
That make it better.
That make it better,
yeah.
yes.
Because we already know which portions of which genes are really important for infecting cells. And, sometimes, you hear HIV, it mutates, but at the same time, it has sequences that never mutate. You can sample it from various patients, and certain amino acids are always the same. And at other times, you can chop out a bit from one virus and put it into another virus, and they switch behaviors. So we already know which regions are important, but if I can randomize those regions and then give them tasks, then we can actually study it in a laboratory instead of just going out and seeing what we can find in the population. Because, again, HIV mutates so quickly, maybe the guys that transmitted are outcompeted by other variants right after transmission.
Right. So can you use those constant regions that don't change much as handles to...
No. There's one portion of HIV that is good for antibodies, but it mutates all the time. It's coated in sugar. Yeah.
Okay.
Your immune system just can't catch up to it. But at the same time, if you can identify which structures are the most immunogenic, and you can still neutralize the virus with an antibody, there are ways around it. The problem is that naturally your immune system can't catch up. But if you vaccinate and you give your immune system a head start to kind of nip the infection in the bud, then you have a chance.
Right. Okay. Well, it sounds like you're trying to save lives or something like that.
Yeah, as evil evolutionists doing terrible work like HIV research, so.
Yeah, well, science kills people and all that kind of stuff.
Science does, yes. You are kind of a Nazi.
So, one thing I'm curious about, it's been a while for me, what's it like being a graduate student nowadays? Are things cushy and soft, unlike when I was younger?
Yeah. They're feeding us steak dinners every night, and yeah. No, I don't think things have changed all that much. I mean, the good thing about grad school is they do pay you. Like, there is a stipend.
Yes.
But at the same
But not much.
Not much, and at the same time, the stipend is pretty much standardized. So it's the same amount whether you live in San Francisco or whether you live in Oklahoma. So I think I have it better than, for instance, the kids that live in Boston simply because of cost of living issues.
Yes.
But I don't know. It depends on your boss, how things are. But I've got a really laid-back boss who's just like, if you get the work done in 4 hours a day, then just come in 4 hours a day. But the thing is that that never happens.
I don't know if we should encourage that.
Yeah. Well, heck, if you're getting the work done, if you're getting the data, he doesn't mind. The problem is you're still there 10 hours a day because you can never get enough data in 4 hours a day.
Right. That's what I tell my students who are going off to graduate school is expect not to get paid much.
Yeah. Don't ever calculate how much you get paid per hour. Just don't do it.
Right. And the number one thing to have a successful graduate school experience is to have a good advisor.
Yes, absolutely.
That's what matters. I've known many students who've just suffered, and it's largely because their advisor may not be an evil person, but they
just personality-wise.
Clashes and in these times with funding pretty tight for PIs, there's often a lot of tension there that some will express in less than pleasant ways for the graduate students.
Well, I will say it's definitely if a student out there is interested in graduate school, try to do summer research. Not only to see if you like research in the first place, but also to understand lab dynamics. And sometimes you just don't fit in personality-wise in a lab, and that doesn't make them a bad lab, and that doesn't make you a bad student. It's just I would not be having as much fun if I were in a different lab that might be great. You've got to try on different hats to see where you fit in.
Yeah, that's another key point is, they're not paying you much, so if you're not having fun, you shouldn't be doing it.
Oh, yeah. Because I see my grad student buddies more than they see their spouses, so you really need to like the people you're working with.
Oh, yeah. No, I actually got married my first year of graduate school, and she was a graduate student, too. So
you also saw each other about 5 minutes every week?
Yes.
Yeah.
Yes. They were a good 5 minutes, but you're stretched kind of thin. So nothing's changed. That's good to hear.
Yeah, no, not really.
Oh, one other thing I wanted to ask about the graduate student experience nowadays. What I'm seeing at the undergraduate level, I'm in an entirely undergraduate institution, is that in biology we're seeing many more women.
Oh, yeah.
And I hope that's translating into both graduate students and faculty.
Well, here's the deal. I went to a liberal arts college too, and the majority of my classmates were female in the biology department. Mm-hmm. And then graduate school here, I think it's 85% of us in my entering class were female. And then in the micro department, we're all female except for a handful of male grad students. So there's women all over the place, right? And then you look at our professors, and there's
they
two.
look like me.
Yeah, yeah. And I don't mind that. They're great professors. That's fantastic. But it feels weird, but I think it will get less weird as my generation gets older, and because I know myself, I haven't encountered any sexism yet, and if I have, I've been too oblivious to notice. But I grew up in a really pro-science family, even though I grew up in a farm town, and I went to great high school, have great science teachers, I had great science professors in college, I have a great mentor now. So I'm not sure if I'm the best person to talk about sexism in science these days, just because I personally haven't had to deal with it, but at the same time...
Not directly, yes.
But at the same time, I know it's still out there.
Right. Yeah, and that's just another thing to watch for. That's another part of that experience of what is your PI like, and we old gray males might be in greater numbers now, but since all of our students are turning out to be women, we're starting to adjust, I think.
Yeah.
So, yeah.
But as far as just things that I've heard, it's there's the stereotypes of women who are successful in science, and it's either the classic, she slept with a famous PI something or other, flirted with this famous person, that famous person, or it's you act like a man, you're aggressive like a man, you talk like a man, so that's why you're successful. It's because you might look like a woman, but you're really a man. And I know that stereotype gets slapped around a lot in research.
Hello? Oh, I just heard some static.
Oh.
Are you there?
Yeah.
Yeah.
Okay.
Okay. Oh, yeah. Well, now though that brings up an interesting point, because I've often heard you described as brassy and loud.
Oh, yeah.
Yeah, people on the web are going to say she's...
I'm an atheist and a scientist, and so I'm a man.
Yeah,
I've
just
just
like
it.
Madeline Murray O'Hare
Yeah.
and Margaret Downey and all these other people leading atheist organizations. They're really men deep down, right?
Oh, yeah.
Yeah. Yeah. Okay, well, so that brings me to another point, that I get some criticism, and I know you do too.
Oh,
that
yeah.
We have a less than gentle approach to communicating science.
I think we reached that point from very different starting points. Because, like I said, I grew up in a very pro-science family. And so to see anti-science, I didn't even know creationism was real until I went to college and Kent Hovind came to campus.
Oh, no.
And I saw this advertisement in the school paper for Dr. Dino, and I was like, sweet, I love dinosaurs. Because, when you're older than 5 years old, you never get to talk about dinosaurs. So I was so excited. And then it turns out I had, a test or something the next day, and I didn't get to go. And so I was talking to one of my professors, and I was like, oh, man, I didn't get to see Dr. Dino last night. I was so excited. And I will never forget, my professor just stared at me, and, his jaw was on the floor. And he was like, don't you know who that was? And I was like, no. It's like, he was a creationist. And I just stared right back at him, because I didn't know what that was. And so it's a very foreign society for me. And so when I confront it, I'm just saying how I see it, I guess as a foreigner.
Well, I don't think you say anything that's too different from my experience either. I grew up in the Pacific Northwest, which is one of the most godless parts of the country, full of unbelievers. And my family was lower middle class, but they weren't anti-science. They were kind of interested in it, but there was nothing negative associated with it. So, yeah, I experienced the same thing when I first started hearing about creationists, that this is unbelievable that here in 20th and now 21st century America, people are still loudly proclaiming this bizarre nonsense. And even worse, that they have hordes of people in the audience who are cheering them on and going along with it.
Hallelujah.
Yeah. Yes. So you may have missed Dr. Dino, but I heard him a few years ago. Have you caught up with him since?
No, just that he's in jail now. That's all I know about
him.
I never watched any of his stuff.
Oh, it was terrible. I really don't understand how people can claim that scientists are poor communicators after listening to Dr. Dino. That he gave a PowerPoint presentation with 700 slides.
I get the exact same thing, because Billy Dembski came to OU last fall, and I heard so much about creationists are so suave, and they're great speakers, and they're these great communicators, and he was stuttering. It wasn't entertaining. The audience did not respond well to his presentation. It's just, I have heard some really bad lectures as a student, and I have a lot of examples of what not to do, and I would not put the creationists I have seen on this fine communicator pedestal that some have.
No. In the case of Hovind, he went over well with his audience, but it was largely because, along with his shtick, he was telling the most appalling, racist and sexist, but folksy little jokes the entire time. Which, I was listening to this, and I could not believe that in this day and age, somebody would get up there and start making jokes about Jews. in a public lecture. Not degrading jokes about Jewish people. And there he was, and there were the people cheering him on. So it's a different strategy, I guess.
Yeah.
Yeah. Let's appeal to people's bigotry, and that way they'll like us.
Yeah. Well, we can't offend anyone, PC.
Right.
We don't want to offend people.
Oh, who, me?
Yeah. I don't do those things.
Right. Yes, don't say that now, because I've just raised the ire of Bill Donahue.
I know.
Yeah. He wants my head on a platter, I think. He's fired off. His minions have fired off many emails to my university president, and we're actually going to have a meeting next week to talk about this stuff.
Good.
Oh yeah. So that's going to be interesting.
When I got invited to Science Blogs, the first thing I did was I went to the head of my university, and I was like, I'm going to be a blogger. You might get some emails about me at some point in time, but I wanted to make sure my university was okay and wouldn't retaliate against me. And I don't say what I'm doing is endorsed by the university. I'm just a student at the university. And, basically my rules were don't do anything to ruin your career. And you know what? I don't think I've offended anyone that is in a position that would ruin my career. I don't think offending William Dembski is not really going to affect me in the long run.
Except maybe in a positive way.
Exactly.
That's actually a good
and
thing.
Definitely, it has been a positive experience.
Yes, and in general, I think the university systems are fairly supportive of free speech, and that we can do things like criticize religion and criticize creationism, but I think they are often operating in kind of this abstract vacuum where they've got a commitment to the principle. And then what happens is they suddenly get all this email or mail from outraged people of some religious persuasion, and then they start rethinking everything. And I think that's what they're going through right now. I'm pretty confident that there will be a respect for free speech, and it's not going to be a serious problem. But I bet you they're a little discombobulated right now that suddenly Bill Donahue is coming down on them.
I don't know. The higher ups seem to think my blog they think it's cool. They think it's neat. So, so good luck with that. And in all doubt, you can come down here, come to this university. They'll support you. It's awesome living in Oklahoma, PZ. It's awesome.
Yeah, I've experienced some of this. That there's this kind of bias that. The farther south you go, the more weird and the less supportive of things like atheism and science there's going to be. But it's not really true. What you find is that there are people in these places that, because they're in this area that's got this reputation, they are much more overtly supportive of people who are willing to speak out. So, I'm going to Atlanta next week, and I've just been hearing all these wonderful things from people down there in Georgia, telling me they want to meet with me and talk with me, and they've got their own voices that are all pro secularism, pro science, good things like that. It's a good thing to hear about. So.
Oh yeah, and I know the guys in Oklahomans for Excellence in Science Education.
Oh yes,
they work so hard here. And, at the same time, people tell me, why bother? They're creationists, let them be creationists, let them have little creationist kids. What's it matter to you? And I'm glad there are organizations like Oklahomans for Excellence in Science Education fighting for those kids' education. Because there could be a kid, just going to public school, grow up in a creationist house, but he might have the capability to be the next, Einstein, the next, cancer researcher, might cure AIDS. And he's not going to have the same opportunities as he would if he grew up in a different city that actually supported science education. And who knows how many inquisitive minds we've lost because of this. And I'm glad there are still organizations stepping up in the places that can feel lost to the cause.
Yes, exactly. I mean, we can be accused of being elitists, but I think when you get right down to it, we're exactly the opposite of elitists, because we're saying that there are all these good kids down there and everywhere in, up here north too, that we shouldn't write them off. We shouldn't be saying, well, they're creationists, send them away.
Yeah.
We want them to be members of our society. They're contributing members of the scientific community.
Well, if they want to be, I want them to have the same opportunities as any other child would.
Yes.
I mean, I'm glad there was somebody fighting for me in Missouri when I was growing up, because I had a great science education that included evolution and included, all kinds of science. And it just, the disadvantage some kids would have to go through just because of where they're born, especially, in a place within the United States. How can you stand for that?
Right. Yeah. And that's another thing. I keep hearing from these people in the South, and they tell me about these great science educations they got. Now, when I was in high school, I got a crappy science education. It's not fair. I mean, I was a Yankee. I was in Seattle, and my high school science classes were pathetic. They were terrible. My physics course, the professor or the teacher just sort of gave up, and he said, "This is all self-taught. You just read the chapters, you do the quiz at the end." And I ended up spending that entire term playing cards in the class. And biology was not much better. They were all just, this is not something we're going to invest in, is the impression you got from the administration and the teachers, and we all had to be self-taught if we wanted to study science.
I had the same teacher in high school for science as my parents had. He was awesome. He was great, but he finally retired, I guess, my junior year. But man,
oh, your kids are going to be left out.
Yeah, he was just the perfect, crotchety old scientist. But man, he was awesome. But I will say, biology in elementary and middle and high school, I gotta say, when I was growing up, I didn't really like biology all that much, because a lot of it just felt like memorization and not really interactive as much as biology can be. And I again grew up in a small town, so I thought if you like science, you either became an engineer or a doctor. And I have actually experienced some sexism with engineering, so I was like, well, fine, I guess I'll be a doctor. I'll go into biology. And it wasn't until I got to college where I got to do some open-ended experiments, not just cookbook biology. And, I really understood what biology and what research was, that I was like, wait a second, I don't want to go to med school. It's like, I want to do research forever. And I didn't even know that was an option until I got to college.
Yes. That's engineering and medicine, that isn't science.
Yeah. Well,
that's applied science.
When you're in a small town, there aren't any PhDs around. I didn't really understand what a PhD was. So I thought, engineer, MD, that's just what you do if you're good at science.
Right. Yeah, I mean, I see the same thing in my students now. Is we get, so biology here is probably the first or second largest major on our campus.
Yeah, it was at my university too.
Yeah, we kind of swap off between us and psychology on alternate years. And we get all these students coming in, and most of them think they're going to be doctors. And what they think the biology course should be is they come in and they memorize things. They memorize bones, and they memorize muscles, and they memorize this and that. And our introductory biology course is nothing like that.
Oh, yeah.
Our introductory biology course is an overview of evolution and genetics.
Yep.
And I also toss in a fair amount of history and philosophy of science as well. And they kind of freak out over this. They don't know how to study for it, because if it's just a list of things, they can memorize a list. They know how to do that. But if it's something where they have to understand the concepts, and where when I give them a test, I throw them a problem they've never seen before, and they have to apply their understanding to puzzle it out, they get kind of cranky. It kind of hurts some of my student evaluations, which I hate.
If it makes you feel any better, my experiences were very, very similar with classmates and their expectations and what they thought classrooms should be and such. But on the bright side, they wouldn't take certain professors because they were the hard professors that made them do a little more. So I loved to sign up for those professors because they were awesome. They were awesome.
Yes. Yeah, it's a weird thing that they really don't mind working. Students are ready to come here and start learning, and that's a good thing. You just have to get them out of that false impression of what it means to learn.
Yeah.
There's more to it than memorizing the textbook.
And that's not the fun part of biology. I mean, it's gotta be the baseline, because you have to understand the terminology and you have to start somewhere. But it's after you learn the basics, it's after you memorize the textbook that things get fun. Yes,
that's what we were saying earlier about graduate school. You should be doing it because it's fun. And I don't know anybody who thinks sitting down and memorizing something is fun. They may think of it as a good job, a good task to get them through something, but it's not something you do by choice.
Yeah.
But on the other hand, going in and, I don't know, taking apart a fish or taking apart a virus and trying to figure out how it works.
No, what I do, I set up steel cage death matches between various kinds of HIV. And no, dude, they glow. When they infect cells, the infected cells will glow, either red or green, and sometimes I also make them radioactive. I have the best job on the planet.
Oh, well, do you get to work with lasers?
Yes.
Oh, you do have the best job.
I have the best job ever.
Okay.
Yes, I use flow cytometry to count how many green cells and red cells I have. So I get to play with lasers a little bit, though most of the time, if I'm working with the laser, I'm usually cursing at it. So.
Oh. Okay. Well, still, that's pretty good. Yeah. The fun thing about my particular research is I do things like time-lapse microscopy of developing organisms, developing tissues, and so students like it because it's research where you watch TV.
Oh yeah.
Yeah, it's really nice because you set up your experiment, you put it on the microscope, and you aim the cameras at it. And you have to fiddle with everything and adjust everything so it's perfect. And you push a button, and then you go away and leave it alone. And you don't have to do anything, and then go off and study and play and do whatever.
Yeah.
And then you come back a few hours later or a day later, and you get this nice movie, and you start analyzing, which is sometimes harder.
Yeah.
Especially if the movie didn't work or something went wrong with the animal.
Okay, that is one bit more of grad school advice that I want to say. That, things don't work a lot. If your experiments worked the way they were supposed to every time, you would get a PhD in like 9 months. But things never work, so you have to be able to troubleshoot. You have to be able to understand. Again, going back to the memorizing things, you need to understand the biochemistry of the procedures you're doing. So when things go wrong, you know how to troubleshoot. You know how to make them work the next time you try it. Because I know a lot of my work is doing the experiment over again because you messed something up the first time. And I know our summer undergrad gets a little frustrated that she does these things, and I'm like, oh no. It's like, you do them as a grad student, you do that as a PI if you're still doing research. Because don't get frustrated when things don't work. Right.
Yeah, and the other element that I've been discovering is, since I am at an undergraduate institution, I'm working with entirely undergraduates, is just the technical and mechanical details of an experiment. That you and I have skills that we don't even appreciate. We take them for granted, that when you have to sit down and work with an undergraduate, you discover that they can't do things. One good example is I'm working with zebrafish. They're little tiny embryos. The larvae are 3 millimeters long, and you've got to use a pipette to catch them. And students come in, and this is their first frustrating event. Is you give them a beaker full of fish, and you tell them, "Okay, give me one." And
3 hours later. Oh.
Yes, but once you do it for a while, you just work at it, and suddenly those reflexes kick in, and it starts to become natural, and suddenly the mere technical details stop getting in the way of doing the experiment.
Oh yeah.
And it takes time for that to happen, and a lot of students get frustrated at discovering that little impediment to progress. Okay, you stop talking.
I know.
Sorry.
Let's see.
What else we're going to talk about here?
I know we had a list.
See, we talked. Oh, what have you been reading lately?
Oh, geez. Okay, so what I've been reading lately, for like the past year, again since I started grad school, is papers. I have had Craig Venter's autobiography sitting on my desk for 6 months now, and I've read like the first 5 pages, but then I don't have as much time to do as much recreational reading as I would like. So I've read a ton of papers, but recreational, that I do hate that. Because I was a huge reader when I was younger, so I mean I'm still reading a lot. It just it feels what do I want to say? I feel defeated because I'm not reading as much as I used to.
Oh, yeah, I confess to some of the same situation that I've been reading a lot of papers too. I mean, I've been finding that I've been going more and more towards review papers and so forth lately because I've had to write all this stuff that's summarizing things. But I've been reading a lot of stuff on metazoa and evolution lately, and a lot of stuff on general principles of Evo-Devo, because I've got to go give this talk next week where they expect me to summarize Evo-Devo in an hour.
Oh, yeah. Well, at least you get an hour.
Oh, yeah. Yeah, but still, it's just boiling it down. That's been trouble. And then, of course, the other thing is nowadays I get so many books from people who want me to review them that the stack of books, it's huge. That it's sitting over there staring at me, and so I have to force myself to plow through.
Oh, and then you might not enjoy them as much as you could if you weren't under as much pressure.
Although, it used to be that if I picked up a book and started it, I was compelled to finish it, and that's gone away now. If I start reading a book and it's horrible, I can close it and I can put it on the shelf and then say, okay,
because you have 20
I'll
others.
go read this other one. Yeah. So there have been a fair number of, and I feel kind of bad about it because people send me these free books. They want me to review them, and then I maybe review 1 in 10, but trust me, this is the good thing, because if I reviewed the other 9, they would not be good reviews. So.
Oh, actually, yeah, I have reviewed, quote, a couple of books on my blog recently. Just a couple more creationist screeds that have come out, and they put a chapter or 2 online for free. So I was like, well, why not? Maybe there's something new. Maybe there's something different. And it's not. It's all the same thing, just repackaged, different title, different cover. It's all the same. Yeah. And I think over at Sandwalk, Larry had, what was it, a review of what, a response to atheist and the God delusion. And, it's this great response. And it's the exact same arguments that have been here for 2,000 years. And yes. I've just found I've gotten so bored with creationist books. I mean, after Behe's Edge of Evolution gave me so much fun, I don't think anything's going to top that. But still, you were
using fun in this sarcastic, ironic sense, I presume, right? Because
no, I really think I get amusement out of it. I guess I really do. I think they're funny. I'm not as disgusted, I guess, as some people might be, but I really do think they're funny sometimes. And
right.
And the last couple I've read, it just feels like I'm reading the same book over and over and over again.
Yeah. Yeah, I kind of resent some of the creationist books because those I actually do feel an obligation to plow all the way through, even though they usually are total crap.
If Michael Behe doesn't feel an obligation to use Google before he writes his book, I don't think anyone should feel an obligation to read it all the way through.
Yeah, except the thing is, if you're going to criticize them, right? Because you're going to rip into their arguments, and if you have to admit that you didn't read every last word, that's all they will harp on.
Oh yeah.
For instance, a while back I reviewed Denise O'Leary's Spiritual Brain, and this is an appalling book. She is the best writer on the planet, PC. Oh,
how dare you say that? I can't believe you just said that. She is my idol.
Oh dear. Well, but this is a book where I felt obligated to read it, and normally I would say, okay, I've got to finish the whole thing so I can criticize it thoroughly. And this is a book I could only make it halfway through because it was so bad.
Okay, I just picked it up in Barnes & Noble and flipped through a few pages, and it was almost unreadable, at least for me.
Yes.
So I don't know how you did that.
I don't know
amazing.
either. I mean, she had factual errors all over the place.
Well, it's not even that. It's just like, okay, I'm the last person on the planet who should be critiquing someone's grammar and sentence structure. But holy crap! I mean, I physically couldn't read it. It was English words. I think the word I use most often with her is word salad, a coagulated word salad.
We could say it's Canadian, but then Larry Moran would beat us up.
It's not his fault.
No, it's not his fault. Yeah, and then the other thing is she would write these, she'd write maybe 2 or 3 paragraphs, and then she'd just vomit up all these quotations. Many of them completely irrelevant to what she was talking about, but somehow in her brain they must have meant something significant. So that was an example of one that, I didn't want to read through, and I tried my best, and I'm kind of impressed myself that I actually read halfway through it. But now if you go to Denise O'Leary's blogs, and what you'll find is she is so angry at me, and most often what she'll say is, oh, he didn't even read the book.
Well, she must have stumped you if you just couldn't read it all the way through. I mean,
it's an interesting strategy is make such a gag-worthy book that no reviewer can get through it, then you won't get any negative reviews. Right?
Of course.
Yeah. You won't get any good ones either, but, I don't think her book did very well.
I don't think, amazingly. So we make fun of creationists for putting out all of these books, and, they make blog posts, buy my book. But at the same time, they really don't do all that well. Because I know I was just making fun of Michael Behe. His book just came out last year, and it's already $6.99 in Amazon's bargain bin for a hardcover book. Whereas, the God Delusion...
And it's still no bargain.
The God Delusion came out years ago, and it's still, it's got a little discount on Amazon, but it still has a market value. But I bet they'll be coming out with new editions. Yeah, there'll be new editions of that coming out. I think it's going to hang in there for a good long while. Yeah, that's the other weird thing is in this culture, they've got so much influence, they get so much prominence, and the newspapers all have to consult their pet creationists to balance the science. But when you work with them for a while, you discover that there aren't that many. There's a few names that come up over and over. Dembski, Behe, the Discovery Institute, and they don't have that much of a readership. They're small potatoes in the blogosphere. Oh yeah. I just got a link from Uncommon Descent this morning, and it hasn't even blipped my site meter above normal. Same here. I don't even notice these things anymore from them because, today I'm seeing a big traffic surge from a lot of different places, but no, Uncommon Descent doesn't show up on the radar at all, and I think Uncommon Descent is probably the big one of all the creationist blogs out there. So, but I think the support you see in just generalized polls by a newspaper, this, that, and the other, is ID on the surface is the universe is so complex it must be designed, and that appeals to a lot of people who believe in God, and it sounds reasonable, but the difference between an intelligent design creationist and a theistic evolutionist is that the creationists say that they have proof. You know, Michael Behe says, well, HIV has evolved. They have proof of exactly when and where their God has intervened. And, you know, average Joes don't know that. So they're like, oh, yeah, you know, teach the controversy. Teach both sides. You know, things are complex. And so I think, you know, at least our side, we need to get the message out there that, no, that's very different what ID is saying and what people think it says.
Yeah, well, the message I've been trying to hammer home is that, yes, everything is complex, but complexity is not an outcome of design.
Mm-hmm.
Design tends to simplify and streamline, and it tends to remove, you know, unnecessary and redundant parts. And when you look at biology, what you find is this Baroque mess.
It's a mess.
This
it's a cool mess, but it's a mess.
Yes, it's very cool. But complexity is, you get more complexity out of random processes than you do out of design processes. And that's, I think, one of the messages we have to put out there to counter this is that, you know, go to a beach and you look at the beach, and what you'll see is grains of sand everywhere, and you'll see driftwood in these amazing shapes, and you'll see these little tide pools with, you know, scatterings of organisms in them. And it's extremely complex, but you know that there was not a gardener who came in and placed each of those bits and pieces. It was chance. It was storms that threw this up. It was weathering, and it was geology and history that did all this. And you know, we don't make things as complicated as something as simple as a beach.
And just to appreciate things that are cool because they're cool. I mean, again, it's not magic. Driftwood going on a beach is not magic. Epigenetics is not magic. It's just pretty. It's just cool, and I think that's the message I want to try to get across.
Oh yeah, science is beautiful. That's
cool.
Our message, and it's much better than anything that our imagination has conjured up.
Definitely.
Reality is where it's at, and it's always going to surprise us. And you know, we've been talking for an hour. That's probably a really good place to stop. Well, we said something wise and pretty.
Yeah.
Right? So.
Well, and before Artie starts getting agitated, he's still chewing on a bone I gave him a minute ago. But with the pit bull and a chew toy, we've maybe got another 4 minutes, even if we wanted.
Yeah. Well, you know, you should have him say hello on Blogging
Well,
Heads
maybe
before we go.
He's kind of in chewing ecstasy right now.
Oh.
We'll see.
Okay.
Nope, he's chewing. He's like,
He's busy.
Screw you, I've got a chew toy.
Okay, well, maybe we'll have to do it again, and next time we'll have the dog.
Yes, he should have opened. He should have been our opener.
Yeah. Right. Okay, well, it's been good talking to you.
Great to talk to you, too.
And I'll look forward to seeing this, where I will actually be able to see your face on the web.
It's awkward. This is really awkward staring at myself on the computer screen.
Right, yeah. Well, you think it's awkward for you. Think about me. What do I have to look at here? Okay, goodbye, and it's been fun.
Yeah, see ya.
Yep.